Good morning, everyone. My name is Michelle Valerie, and today I would like to present our research proposal entitled A Digital System for Monitoring Classroom Brainstorming and Learning Process. It's a quasi-experimental designs comparing BIMS and sticky notes based brainstorming. And this research is conducted under the supervision of Dr. Chung Min Lin at Tsinghua University. And today I will introduce the background of our study, explain the proposed research design, and finally report our current research progress. So let's begin the presentation. Okay, so brainstorming is one of the most commonly used activities in classroom because it encourages students to actively share their own ideas and participate in the discussions. However, traditional brainstorming using a sticky notes maybe still has a several limitations. Like for the first one is often have an unequal unequal participation because maybe some of the students might feel shy or lack confidence to express their own opinion. And the second one is the ideas generated during the activity are difficult to preserve, making it challenging to review or maybe analyze them afterwards. And the third, the teachers maybe have limited visibility of students' interaction throughout the brainstorming process. And finally, documenting every discussion manually requires a significant amount of time and also effort. And because of this challenge, we believe that a digital solution is needed for a better support classroom learning as well as educational research. So this is our research motivation. So because based on this limitation, our research teams develop a digital brainstorming platform called BIMS, which stands for Brainstorming Interaction Monitoring System. And unlike a traditional brainstorming, BIMS allows brainstorming activities to be conducted digitally while automatically recording every interaction between the students. So this enables teachers and the research to observe students' participation and learning process more effectively. So our goal is not only to improve the classroom brainstorming, but also to provide a reliable research data that can support future educational studies. And this is our research objective. So this study have five objectives. So the first objective is to develop a robust digital brainstorming platform called BIMS. And then the second objective is to compare the effectiveness of BIMS with the traditional sticky notes brainstorming method. And the third one is to evaluate students' participation, including how actively and equally students can contribute their own ideas. And for the fourth objective is to monitor students' cognitive learning process throughout brainstorming activities. And finally, we hope to provide a reliable data that can support future educational research. And this is our system overview. Okay, so let me introduce the BEAM system. So the BEAMS is a web-based brainstorming platform designed specifically for educational settings. And the system is hosted on a GitHub page, while Supabase is used as the database to securely store all the interaction data. And one important feature of BIMS is anonymous participation, which allows students to express their ideas without worrying about social pressure. In addition, the system supports real-time updates so that students can immediately see the new ideas that contribute by their classmates. And overall, BIMS provides a more interactive and research-friendly environment for classroom brainstorming activities. Okay, so this is the key features BIMS have. BIMS provides several important features that support both teaching and also the research. The first one is the anonymous participation. Anonymous participation can help reduce students' psychological barriers when sharing their own ideas. And the second one is real-time posting. In real-time posting can allow students to immediately view and respond to their classmate contribution. And the third one is threaded discussions. This can organize conversations more clearly and making discussion easier to follow. And another important feature is automatic logging, where every interaction is recorded systematically for future analysis. And finally, teachers can manage each learning phase through the system. This can allowing classroom activities to run in a more organized manner. So together, these features makes BIMS suitable not only for classroom learning, but also it's suitable for educational research in the future. So this is our research design. So our study will use a crossover quasi-experimental design involving two classes. We have a class A and class B. Each class will include approximately 20 students. And in class A, the student will first use a BIMS during the brainstorming activity and followed by the traditional sticky notes method. And in class B, the order will be reversed. This crossover design helps reduce the influence of learning effects and allows a fair comparison between the two brainstorming methods. At this stage, the experimental design has already been complete. However, the classroom experiment has not yet begun because we are currently preparing for the ethics review process. And for the next slide, we will talk about our research procedure. So the classroom activity consists of 6 stages. The first one, the students will complete a pre-response activity to express their initial understanding of the topic. And the next, they will individually generate their own ideas. After that, all the ideas will be displayed for the entire class to view. And the student will then respond to their classmate ideas by providing maybe comments or additional suggestions. And then the discussion will continue with a synthesis stage where students integrate different ideas into more comprehensive solutions. And finally, the students will complete a post-reflections activity to summarize what they have learned from the brainstorming sessions. And this entire procedure has already been designed and is ready for implementation once ethics approval is obtained. And to evaluate the effectiveness of our system, the BIMS, we plan to collect the data from multiple sources. This includes BIMS system log data, physical sticky notes, student questionnaires, reflection forms, and also the photographs of classroom whiteboards. This data source will allow us to evaluate participation, equity, peer interactions, cognitive learning process, and student overall learning experience. And since the experiment has not yet started, so no research data have been collected at this point. But the questionnaire has already been complete. It consists of 32 Likert scale questions and 5 open-ended questions. And the questionnaire measures 8 aspects of student experience. These include participation safety, idea generation, idea feasibility, peer interactions, perceived learning, ease of use, participation equity, and students' overall preference between digital brainstorming and traditional sticky notes brainstorming. And this questionnaire will be administered after the students complete both of the classroom activities. And after data collection has been complete, several analyses will be conducted. First, we will compare students' participation frequencies between the two brainstorming methods. And next, we will analyze response timing to understand how quickly students generate their ideas. We will also evaluate their idea diversity to examine the depth and variety of student thinking. So in addition, peer learning interaction analysis will be performed to understand communication patterns among students, and conceptual change before and after the activity will be also examined. Finally, questionnaire response will be analyzed statistically to evaluate students' perception of both brainstorming method. And at the current stage, these analyses are planned but have not yet been conducted. And we believe that this research can make several contributions. First, it can provide evidence-based strategies for improving activity learning in classroom. Second, it demonstrates the educational value of specialized digital brainstorming tools. Third, automatic data logging can significantly reduce teachers' workload compared with manual documentation. In addition, this study may improve research methodology by applying a crossover experimental design in educational settings. And finally, because BIM is designed as an open source platform, it can also serve as a reusable framework for future educational research. And finally, I would like to report our current research progress. So far, the BIMS brainstorming system has been successfully developed. The classroom activities for both Class A and Class B have also been completely designed. In addition, the post-activity questionnaire has already been finalized, and our next step is to submit the study for academic ethics review. Once ethics profile has been obtained, we will begin the classroom experiment followed by data collection and data analysis. Moreover, the project is currently in the preparation stage and the experiment has not yet started. Okay. Okay, that concludes my presentation. Thank you very much for your attention. I appreciate your time and I will be happy to answer any question regarding our proposed research or our current progress. Thank you so much.